Okay, welcome back, and this is the last in the series of our lectures on kinematics. And just kind of quickly review, we've had 4 equations. X is equal to VT, V is equal to V naught plus AT, X is equal to X naught plus V naught T plus 1/2 AT squared, and V squared equals V naught squared plus 2AX. Might want to put these on a little sheet of paper because today we're going to look at something different. Now, up to now, our motion has been horizontal. But now we're going to do vertical motion. And when you see vertical motion, you're going to have to deal with gravity. Now, gravity is just the acceleration due to gravity. We're going to use the letter G, or know thy units, and you can see that meters per second squared is the same as A. Now, you notice I've got 2 numbers here. I've got 10 meters per second squared and 9.8 meters per second squared. The true value is 9.8 meters per second squared, but a lot of teachers and college professors and some books and even on some exams, they'll let you use 10 because 10 is a lot easier for you to calculate and do your calculations than 9.8. But just be familiar with both of them and go with whatever your instructor tells you. I'm going to use 10 because that's what I use in my classes. So let's look at here. We've got a ball is dropped. So that means we have vertical motion. So that means I have to deal with our G. And it travels for 3 seconds. So that's our time. And I want a velocity. Now, one thing about this, if I look back at my 4 equations, I cannot use this equation because that's not does not have acceleration in it. So I got to pick and choose which of these I need to have. So you can see I have a velocity, so all of them have it, but I have seconds. So that is our time, so I'm down to these 2 right here, and I want a velocity, a new velocity. So I'm going to have to use this one, my equation right here. I want the new velocity. Now it says that it's dropped. So the beginning velocity is 0, and 10 times 3. And knowing thy units, V hasn't changed for us, so it's going in meters per second. You notice here that I made 10, even though it's going downward, 10 is a positive number. My contention is, if it's speeding up, acceleration is positive. If it's slowing down, acceleration is negative. That's a good thing to remember when you're doing these equations. I'm going to keep this right here for y'all to look at. So ball is thrown upward, so that means G has to be taken into account with a velocity. There's the V, and says what is the velocity as after it has traveled 30 meters. So there's an X. So you notice, I'm going to put a little A there since G and A are the same. So I have 2 V's, an X, and an A. Oh, there it is right there. V squared equals V naught squared plus 2AX. So it says what is velocity? Now don't forget that little square because that's important. Now we threw it upwards at 50 meters per second squared. Don't forget that square. And 2. Now it says gravity is 10. Well, if I throw it upward, it's going to slow down. So it's going to have a negative acceleration. And X is 30 right here. So V is in meters per second. Okay, let me kind of move this down a little bit. Okay, it's thrown downward. So there's G, so that's your key word. So there we have an A. We have with a V here. And it says how far has it traveled after it has fallen 5.5 seconds. So there's our t. Okay, so we're looking for how far. So that eliminates this one. So we're here, but we only have one velocity, so I'm going to use this one. And we're using the same format as we have in our other sections. But remember, we're dealing in vertical. So x is 0, and we're starting at 4 times 5.5 plus 1/2. Okay, it's thrown downward. It's speeding up, and it's 5.5 squared. Okay, quick calculation. X is in meters. Okay, move this down. Okay, it's thrown upward. There's our g. So we have a starting velocity, and it says how much time does it take to reach a height of 7 meters on the way up. Okay, we got g, which is our a, so we got one of these. We have it 1v, so we're down to here, and we want to reach a height, so there's our x here. So x is equal to x naught plus v naught t plus 1/2 at squared. Okay, so it want to reach a height of 7 meters. Okay, that's 0 plus, okay, we start out at 16. We're looking for our time, and that's 1/2. Okay, it's thrown upward, so remember that is a negative, and that's t squared. Oh, we have a t squared. Okay, so what you're going to have to do is set this as a quadratic equation and work your way through it. And I know you can do it because that's one of your basic tenets in math. Okay, we'll do one or two more. Okay, we want to determine the height of a bridge, and if you drop something and you do a little timing, you can do it. We measure the time, and what we want to do is see how long we can hit the water. So we have a height, so we drop it. There's our g, which is our a. There's x. There's time. Okay, and I want to know how long to hit the water. So we kind of cut it down to here, so we only have one. Well, remember it dropped, okay? So that helps us with our v naught is equal to 0. So x is equal to x naught plus v naught t plus 1/2 at squared. And you can see that it's 41 meters equals, this is 0. Now since we dropped it, that's 0t, so that basically cancels that section out. No quadratic equation for us today for this one. And since it's dropped, that's going to be a positive 10 t squared. Nice, simple to do. Seconds. Okay, one more, and the rest are on your own. It's thrown upwards, so there's our g with a velocity of 14 meters per second, and it says how high will the object reach. In other words, where does our v is, next v is going to be 0. So let me tell you, this is a popular for a lot of instructors because it kind of takes in a lot of different things. T plus 2ax. Now, we said it's thrown upwards, it's how high, so the second v is 0. Don't forget that squared. And here's another one, don't forget that one, plus 2. Now remember, you're throwing upwards, it's slowing down, so our acceleration is negative, and we want our x. X is meters. The rest of them are on your own. Remember, if you have any questions, feel free to contact me, and we'll see what we can do.